Hello, this is Claire, and I'm going to talk to you about an extension of trigonometry today. We're going to look at the sine rule. Now, this is quite different to the sine ratio, which is sine theta equals the opposite length divided by the hypotenuse. So the first thing I've drawn is a triangle here, and no angle in this triangle is at right angles. So that large one there is well over 90. And these two are acute. So we label this triangle, the corners A, B and C with capital letters. And this time we're going to label the opposite side lengths with the lowercase. So this will be length A, opposite angle A, length B, opposite angle B, and length lowercase c, opposite angle C. Now, the sine rule is used in triangles which are not right-angled triangles. Now, it's quite different. So, let me prove this to you. The first thing we do is we drop a perpendicular line from angle B to side length B. Now, that is at right angles. So, we have formed two right-angled triangles, this one and this one. And it's the height of this triangle, so we're going to call it H. In this triangle here, let's just look at this triangle. We can use the sine ratio. So sine A will equal the opposite length, which is H, over the hypotenuse, which is C. In the same way, in this triangle here, we have sine C equals the opposite length H over the hypotenuse A. So we have two relationships here over two parts of the larger triangle. Now, we're going to rearrange them to make H the subject of the formula. As you can see, that's the only part of each of these that is exactly the same, that is H. So the C in this formula here is divided. When it crosses the equals, it multiplies. So C multiplied by sine A equals H. In the same way here, when A crosses the equals, it will multiply by sine C. Now we have two formulas, or two relationships, and H is the subject of both. So if H equals H, the second part of the formula must also equal each other. So we can write C multiplied by sine A equals A multiplied by sine C. That's Euclidean logic. Equals, equal, equals. Now, we're going to play around with this a little bit more just to put it in the form of the sine rule. First, we will divide out by sine A so that it divides on this side. So C equals A multiplied by sine C divided by sine A. Now we'll move the sine C. By dividing out by sine C, it will cross over the equals and divide on this side. So we will have C divided by sine C equals A divided by sine A. Okay, we'll rewrite it up here so it's not quite so squashy. And it's usually written side length A, the ratio of the side length A divided by the sine of the opposite angle, A, is equal to the ratio of B, the side length B divided by the sine of the opposite angle B, and it's also equal to the ratio of side length C divided by the sine of its opposite angle, which is sine C. And if I worked further, I could certainly prove that entire thing to you, but it would take some time. Okay, now you usually only use 2 parts of this. You don't use the 3 parts in one go because it's just not necessary. So if you have any triangle, so if I just quickly draw a triangle, and it's a non-right angled triangle, so I'll be very careful that I make it look like a non-right angled triangle. So we have, if you have any opposite relationship, so if you had, say, 40 degrees here and you had 10 over here, you have a pair. You have a pair, a side length and an opposite angle. And then if you have any piece of information, any other piece of information, so if you had that this was, say, 20 degrees, you could use this pair here to calculate the opposite side length. And you could therefore also calculate this angle here and also calculate that side length. But you do need a pair, a side length and the opposite angle when using the sine rule. So in the next tutorial, I'll explain an example of actually how to use it. Thanks for listening. Bye for now.